Here is a demonstration unit of short wavelength infrared, SWIR. The board connected to the main unit has one photodiode, and one LED of each of two different wavelengths. The main unit has switches for each of the two LEDs, and a level meter for the light output. The higher the sense light output, the brighter the light on the lamp on the right side. Let's compare with water and without water. When there is no water, when filled with water, the value at 1050 nanometers remains the same, but the light at 1450 nanometers is absorbed by water, greatly reducing the output. Light at 1450 nanometers is absorbed by water and its output is lowered, so the difference in output between 1550 nanometers and 1050 nanometers can be used to detect the presence or absence of water. Next, let's compare dry and wet paper. On dry paper, neither value changes, but since light at 1450 nanometers is absorbed by water, the more moisture the paper contains, the lower the output. Since the output fluctuates more with moisture content at 1450 nanometers than at 1050 nanometers, the difference in output can be used to detect the amount of moisture contained in the paper. Now let's try it with a metal plate and human fingers. The metal plate does not absorb light and both values are high. The other side, in the case of a human finger, the light is absorbed by the moisture contained in the skin, especially at 1450 nanometers, and the value is low. By detecting the moisture contained in human skin through output difference, it can be applied, for example, to a system that switches on only when a person approaches. Next, let's compare it to near-infrared light, NIR and SWIR. When compared to dry paper and a human finger, both have the same value in NIR. In SWIR, there is a difference in the value detected because it is absorbed by the moisture in the skin. NIR can also determine the presence or absence of an object, but the value is the same for both paper and human fingers. SWIR, it becomes possible to detect differences between human skin and inorganic objects. By using such output differences, it is possible to set thresholds and condition the switches to turn on only when the threshold is exceeded at 1050 nanometers and not reached at 1450 nanometers, for example. Please take advantage of it.